All right, we're moving on to scientific notation today. Your learning target, you can translate between standard and scientific notation. That's what you're going to be able to do today. So you need to know what that looks like. Scientific notation looks like this, like 3.12 times 10 to the 30th. Scientific notation is special because of this. You times by some 10 to some exponent. Standardly, we don't ever go, hey, times it by 10 cubed. Standard form would be something like 4,126. That's standard. It doesn't have a times 10 to some power. So we need to be able to work with both forms. And once you learn the few rules involved, it's pretty easy to translate. So here's the rules of scientific notation. Decimals move left or right. Always. Whatever's moving is the decimal. It's kind of like in 7th grade or 6th grade science when you did King Henry died unexpectedly drinking chocolate milk. When you moved that decimal around, it's the same thing with scientific notation. If the exponent is positive, you go to the right. If the exponent is negative, you go to the left. And then the numbers, there's always 1 to the left of a decimal. Meaning 4.3, 1.02, 1.6, 2.3. One number to the left. 1, 1, 1, 1. So if there's more than one number to the left of a decimal, then it's not in proper scientific notation. So our main properties. Scientific notation looks like a number times 10 to a power. What happens is the decimal starts moving. It moves either left or right. If the exponent is positive, like 10 to the 6th, I would move to the right. If the exponent is negative, 10 to the negative 3, I would move to the left. In my numbers, there's always 1 to the left of my decimal. Okay, let's start practicing. Oh, darn it. So, probably not my first choice, but we'll just roll with it. So if we write numbers in scientific notation, you want one number to the left, and then determine how many spots I would need to move to get to the end. And that would be your exponent. So however many spots it takes to move to get to the original end will be your exponent. And you never include zeros in it. So, where should my decimal go? Right after the first digit. So I write this as 4.4. Now notice how all the rest are zeros? I don't write that. And then I say times 10 to the, and I need to figure that out. So if my decimal was right here, I want to know how many spots to get all the way to the end. 3, 6, 9. So it's 4.4 times 10 to the 9th. I always want one number. So I look to see where is my first number. 4, I put a decimal right after it. So this one should be 4.21. Now see all the rest are zeros? I don't write those. Times 10 to the, I gotta count how many spots to get to the end. 3, 6, 9. Great.
You always count by?
I just grouped them. No, typically I would count by ones, but it would just take forever. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. I just grouped them because I saw my groups of 3 and I can do that fast. Okay, next page. So I look for my first non-zero number, which is 7. Do you see how it's 7? I put a decimal after the 7. So this is going to be 7.5 times 10 to the, and I need to figure out how many spots to get to the end. So if I'm right here, and this is where I'm going to count by 1, it's not as easy for me to group by 3s. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 again, but to the left. So if it's to the left, it has to be negative 9. Okay. Next one, decimal goes right there, right after my 3. My first digit is 3, put a decimal after, so I'm going to write 3.105. Do you see how all the rest are zeros, so I stop there. Times 10 to the, and I got to figure that out. Here it's easy for me to group by 3's again. 3, 6, 9. Please know that I made horrible examples. It won't always be 9 or negative 9. It's just somehow worked out that way when I made my examples. But the strategy is the same. You either move to the right or you move to the left. If you move to the left, it's negative. To the right is positive. And there should always just be one number to the left of the decimal. Okay, now when we convert from scientific notation to standard form, we just move the decimal, box that up. Move the decimal as many spots as the exponent tells you. Okay, so 3.2 times 10 to the 5th. The exponent says move the decimal 5 spots to the right. So here's 1 spot to the right. How many more spots do I have to go? 4. So add 4 placeholder zeros. So it's 3, 2, and 4 placeholder zeros. Now you could get really old school and add 1 at a time. Like if it was 3.2, you need to know, you need to move 5 spots. You could say there's 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. But I think more logically about it. I say, okay, I moved 1, I have 4 more to go, so I need to add those placeholders. Okay, next one, 10 to the negative 5. What direction do I go, left or right?
Left.
How many spots? 5. To the left, 5. So I'm going to the left 1. How many more spots do I have? Huh? 4. So I'm going to go 4 placeholder zeros. So point, 1, 2, 3, 4 of them. And then the numbers they gave me. 2, 0, 4, 3. All right. So last learning objective here, we have to identify if things are written in proper scientific notation. So, and that's part of translating. If you recall, we need to have 1 number to the left of the decimal. If there's not 1 number to the left of the decimal, then it's not in proper scientific notation. So we have to rewrite it. So you can use logic or go a long way, and I'll show you both strategies. 0.387 times 10 to the 9. this is not in proper scientific notation because there is nothing to the left. So what I really need is to have my decimal behind my 3. So you can do the long strategy, which I'll show you at first, and then the quicker strategy, which I'll show you second. So the first thing I would do is turn to standard form first, and then I will rewrite. So this tells me I need to move my decimal 9 spots to the right. So I have 3 spots to the right. 1, 2, 3. I have 6 more to go. So I'm going to need 6 placeholder zeros. So 3, 8, 7, 1, 2, 3. And then 4, 5, 6. That's proper, that's standard. So I rewrote it in standard, and now I'll rewrite in proper scientific notation. So it should be 3.87 times 10 to the, and I need to figure out how many spots to get to the end. 2, 5, 8. That's 8. You can't see it. Let me rewrite it. 8. Oh, I can't see it at all. That's the long way. So what I did is I did what it told me to, move it 9 to the right, and then I rewrote. The logic way, you do a lot of it in your head. In my head, I know that it should be 3.87. I know that. Times 10. Now what's going to change is my exponent. So from here it says move 9 spots to the right. Well, I already moved 1 spot to the right. How many more do I have to move? 8. And it's the same thing. But kids mess that up a lot. So this will never mess you up. This can mess you up sometimes. Okay, I'll do both strategies, and then we'll be done for this next one. So 12.98 times 10 to the negative 5. I need room. So I need to group. Okay, so my long method, move it 5 to the left at first. So I'm going to go standard and then rewrite. 5 to the left. Here's 2 to the left and 3 placeholder zeros. So 1, 2, 3, 1, 2, 9, 8. Then rewrite in proper form. So if I was right here, I would need to move 1, 2, 3, 4 to the left to get to the end. So it's times 10 to the negative 4. So that's my longer method. Lastly, my shorter method is using logic. And I think, okay, I'm supposed to move 5 to the left. But this is not in proper form. I should only have 1 digit to the left, and here I have 2. So I need to rewrite that as 1.298 times 10 to the, well, if I needed to move 5 to the left right there, I already moved 1 to the left. I have 4 more to the left to go. That's how to see that. Times 10 to the negative 4. Done.